If we want to manufacture buildings at scale, we need to really adopt manufacturing principles, manufacturing software. This is in the planning process so that the time on site is as minimal and as fast as possible. Tall Wood House project is an 18-story hybrid mass timber building. It's the tallest of its sort in the world. Most of the building was manufactured, largely built in a plant and then assembled on site. In the case of the Tall Wood House project, our service was to be what they call kind of a virtual design and construction integrator. So essentially doing the digital fabrication for all the mass timber in the building. The Urban One Builders was the actual contractor. We were the virtual one. So we worked kind of shoulder to shoulder them, building everything on a computer screen at an extremely high level of definition so that when they go to build live, it was a lot faster and a lot more of a seamless integration into the project. When we started, we didn't know exactly what the workflow would be because it's the first time anything like this had been built in this way. It was more about getting into the project and realizing how this entire system comes together on a computer screen. We're going to be much more efficient so that when you go build on site, it's going to be very fast. And that's what happened.
It was the first time I'd ever been exposed to a virtual model of it. From that point, we identified issues that we could see that would be a problem during construction. So access, safety, and what would become the critical path of the project. Because the benefit of that is that we managed a 5-day schedule for the concrete installation for every 2 levels, which is remarkable.
The simulation was an important tool for the entire team to analyze the assembly of the full structure and all the components of the building and find the fastest way to do it and the most optimized way to deliver the project. All authoring from a production perspective was done in CATIA 3D Experience on the cloud. All the simulation was done in Delmia 3D Experience as well.
Delmia on the cloud helps with our workflow and managing our time and resources. If I'm really tied up, a colleague of mine who's in a different city or country can take over and work on something or pass it back to me, and that allows us to get things done on time.
Specific to this project, there's a lot of savings that went into the project by having that one data model and in the cloud and anyone can access it at any time. It was a one-to-one data representation. You have the same data that you're using for production purposes as the same data being used for simulation purposes, etc. It's kind of a unique way to do it in a construction project. Much more prevalent in the manufacturing world. For a car or a plane is exactly how they would do it. I think this project was a real positive case for what it means to spend more time in the process of planning, not just the building, but also the process to build the building. In general, when you actually end up manufacturing everything, you can control risk much better, you can plan much better, and you can deliver more with less resources, really. I think that's the differentiator to a traditional concreter.
We're breaking down the traditional construction process into a more scientific manufacturing process. It's only going to grow from there and be more and more valuable.